So welcome back, everybody. Our next speaker, all the way from Belgium, Mike Martin. He's a technical evangelist at Microsoft and he's an ex-MVP as well. And he will unveil the fifth element to us, which is about Azure Secure DevOps. Good luck, Mike.
Well, thank you for that introduction, Sjaakje, and thank you for organizing this. It's great to stay connected to the world, even in these times of quarantine and isolation. So it's good to bring something back to the world. Small introduction on this thing. For those who may have seen the movie The Fifth Element, there is this quote in there that states, "In their possession are the four elements of life. And these elements, when they are gathered around the fifth, the supreme being, ultimate warrior created to protect life." It's for those who've seen the movie, you know that there's the four elements of life called water, earth, wind, and fire. They are gathered around a fifth element, which is magnificently played by Mila Jovovich in the movie, which is a supreme being that is there to protect life. And actually, protection is the same as security. I get a lot of thank you. Protection is also about security, and this is what I mean with when we're doing today development. There's always the one part that we keep forgetting in our life cycle of development, which is called security. So this is a little bit the gathering around it and how we can enforce some of these things and what are the tools that can help you from a free and an open perspective, but also things that Microsoft can provide you on a daily basis. So let's get started. For those who don't know me and want to stay in contact after the fact, there's a Twitter handle here. There's a mail address if you have any question. I know there's a chat going on there. So if there's any questions, feel free to open them. I'll try to see the questions afterwards because I don't have the stream chat open for the moment. So I apologize for that. I forgot to open it. So the narrators can, the moderators can help me out. If there's any questions, please forward them to the internal chat. You can also scan the QR code, so that way it's an easy access to my Twitter stream. So the content of this talk is really on come on, and PowerPoint is failing on me. No, come on. Darn it. Sorry, people. Let me just restart my PowerPoint for a second. I don't want to give away too many details already. Have it. Annoying. So let me continue talking while this is starting. So the goal here is that we have a life cycle in development. One of the strings that is in there, you have your coding capabilities, you have your build capabilities, you have your design of your software, and you have your deployment of your software. And typically what is missing there is the overall security view and how you walk around with that. So if all goes well now, I can open up this slide again. Here we go. So we're back. So as you can see, one of the parts here is a secure design, where you start off. Then what you do typically most is building your software and coding against standards, but also for best practices and for best patterns that are recognized there. And then you can also have, of course, you need to build it. And there we can make a division between scanning your code in a statical way, making sure that you stay away from secure debt. For those who know the concept of technical debt, security debt is also technical debt. And this is the more security debt you have, the bigger your technical debt will be in the end. And there's also everything which comes next to that with dependency management, because you have typically in an application that you're building a lot of packages that you download from the internet, or any package management feeds like NuGet or Maven or NPN that you want to maintain. And there's also dependencies that you create on other people's code that also need to be maintained from a security perspective. Then we talk a little bit about a secure deployment, what you can do there, and how it rises back to secure ops and secure monitoring. And these two are typically forgotten in the what we call the DevOps cycle. It's always the monitoring part that is not always flowing back to the developers and vice versa. And here you can actually see that the monitoring part is very important also for the return on your code to see if anything failed through in your SDLC. So SDLC, or the Security Development Lifecycle, it's a process. There's a full website on it by Microsoft, and it's more on how you start educating, first of all your developers and your stakeholders, then how to meet the requirements ranging from design to implementation to verification, and in the end is taking back the accountability for what you built by means of sign-offs and a decent incident response part. If we take a look into depth, the most important parts here is that you manage a security risk all over the place, that you implement some kind of scanning and analysis of your code before and after the facts. So we have static analysis security testing, which is AST, but also dynamic analysis security testing, doing penetration testing and doing web fuzzing and web testing after the deployment to make sure that nothing passes through, making sure that you can test against some of these tool concepts as OWASP and so on and so on. And then of course, you need a standard set of tools that you need to implement on your entire lifecycle, where everybody signs off onto, your IT organization, that you have the correct licenses, first of all, because you don't want to be a license perpetrator. But you need to make sure that these are tools that you just don't find in an open source stack that are being built and maintained by one guy, but that are fully supported by more than just one community. Because typically they bring back databases with vulnerabilities from third parties and so on and so on. One of the things that are also in there is things like threat modeling, and that brings us seamlessly to the first part, which is the secure design. Now, in the late 90s, Microsoft provided a methodology called STRIDE. And STRIDE is where we have an acronym of 5 letters, which is spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. And what you do typically is you try to think about your software and where all your threats are being identified. Like, for instance, you have you sign in with a user. Can this user elevate its privileges by, let's say, spoofing another user, for instance? Or if you tamper with some of the requests you arise that you can access, does it give you access to something else? How large is the impact of information disclosure, for instance? Do you have any weaknesses or vulnerabilities in your software that can leak information? All these things, they can be made taken into account if you do threat modeling. And threat modeling is a concept where you have a couple of things. First of all, you have what you are building. Then what can go wrong? You think about what can possibly go wrong. what you're going to do about it. So the actual mitigation, and then in the end, validate whether you did a good job for 1, 2, 3, and 4. It's not that hard to do threat modeling. The only thing is that a lot of people see it from, if they're doing threat modeling, they see it from a perspective of classes and like a little bit like UML modeling, which is not totally the same. Here you need to take into account how does information flow through a system, and how can you go from place A to B within your software, and maybe find or come by with some vulnerabilities. This is a little bit more explained on the code. So identify a flow of untrusted and sensitive data in your system, in the code, of course. Document all security sensitive code paths. Documentation is something which is typically forgotten. When it comes down to security, we document a lot, especially on how to use an API or these things, but we never document how security works, or what the things are that we need to take into account if we organize our codes in a different way, for instance, and what the impact would be to, let's say, the usage of other parts. And you should also create security focused models and diagrams. And I'm going to give you an example in just a second how that should look. Because we at Microsoft, and I can say that now since a couple of years, we at Microsoft, we have a free tool called the threat modeling tool. Yeah, it's freely downloadable. And the cool thing about this is, since 2 years now, we have a template that can actually help you use the Azure resources that we deploy, drag them in there, and immediately get all the stride elements that are coming along with it. And from there out, you can actually start designing your model. I have the threat modeling tool open here. If you start it up, it's just a web deployment that it does. So it does live updates every so many times. And as you can see here, there's the a template called the Azure Threat Model template. You can also contribute to this because this is a GitHub repository for that. If you go to the TMT preview, you will also get the help files there, the Getting Started guide, and there you can find the GitHub repository link. But let's see what we can do with this thing. So if you open a threat model model, you actually have on your right-hand side a stencil where you can just draw all the elements that are related to Azure or anything else, because it goes beyond Azure too, of course. But this one is specifically built on top of the Azure template. If you see all these elements that come into play. Like, for instance, I have here a browser, and that browser has an HTTPS connection towards the web app. Now, what it does here, you set all the properties which allow you to define whether let's say whether it's a REST payload, whether it's a SOAP payload, so all the properties that define the connection itself, not really the API or the endpoint results, but more on how the thing would function in a functional way. And you can also say what kind of a flow there's behind, whether it's a physical network, yes or no. Then you have the elements itself, where you can say what mechanisms are you using, and most of them have predefined mechanisms. Now, the beauty of this all is if you take a look at then the analysis view, you get all the mitigations and all the risks that are nicely defined in a list. And from there out, you can actually say whether you started already working on that issue, because it's a checklist that you create, and you actually get all the information what the potential risks are. So there's a process crash or stop of the Azure portal, and that could be a denial of service if you take a look at this thing here. So these define the stride categories. You get a better description. You can set a justification for yourself if you want to. You can talk about the interaction that you have, how you interact with it, and what the priority is of this environment. Now, the cool thing about it is that you can give this model back to as a report back to your CISO and your architects, and you can use it as a full checklist, and it actually will give you per part that you're working on. We just create the community day folder here. So let's maybe just put it here, community day. Here we go. It will generate a full HTML file, and this can you then put inside of your wiki or whatever tool you're using to follow up on documentation, where you can have a nice interface on the content. You see the summary, you see all the parts per part. So the white highlighted part is the part that you're actually going to describe underneath, and then you can see the interaction flow that is going for this part, for instance, elevation. So you can have a full checklist here that you can use to make your software a little bit better and at least understand where the security flaws can be in your application. So start by doing a secure design. That's the first part that you need to do. Yeah. And you can even do these after the fact, especially when you're designing new interfaces. If you're going to do it for large scale architecture that is already in place, it's going to be a little bit harder to process because there's of course a backlog, but try to do then the main parts if you still want to do this. But this can be used for anything. There's other tools out there too, like web-based tools and stuff. But the cool thing about this one is that it can actually work together with an open source tool called Threat Manager from an Italian guy named Simone, where you can have an Excel-based file where you can start working with the results from the threat modeling tool from there out. So, threat modeling tool. Pretty cool tool if you ask me, and it's free. So why not give it even a try? That brings us to the coding part. Now, coding is a little bit more expanded than just the modeling itself. There's a lot of things that you can do when you're designing secure code. And for those who are doing .NET Core, for instance, and you want to work with Azure, because this is also on the Azure development part, we have a .NET Core key configuration package that you can download. It's an extension that you can just download as a NuGet package. You need to integrate that inside of your code, and this will immediately start securing your secrets inside of Key Vault. Now, for those who have never heard about Key Vault is a key management store where you can store your secrets, your certificates, your basically any kind of keys that you want to share between your systems or your solutions that you're building. So this will help you to make it easier on your ASP.NET Core secrets and make it easier for you to configure your environment. Now, that's only for storing secrets, but what if you are like really like neglectable on that you're having a security issue and that you store secrets in your code, which you should never do, by the way. We have a couple of features that we built over the years, and one of them is GridScan. And the Microsoft people that are following this, they probably know this because we have this highly integrated in all our systems when we do builds. But GridScan is a thing that does nothing more than what the word says. It scans for credentials inside of your code. Now, the cool thing is that we implemented this on a GitHub level. So if you're using GitHub repos today and you check in some code with credentials, you will get a warning saying, hey, there's some credentials in your code. Make sure that you do something about it because this is not safe. Because if you store credentials in your code, especially when you're talking about pre-shared keys for storage accounts, for instance, or subscriptions IDs, if people have those, they have a lot of power at their hands, and you don't want to make sure that they can abuse those powers. Now, in Visual Studio, especially 2017, there's a plugin called the Continuous Delivery Tools for Visual Studio. It's, of course, for those who are still working with 2017, this is a very interesting part, where you can download that plugin and it will scan your code from within the IDE. As you can see here, and I just immediately switched to 2017. As you can see here, I have a connection string here. Let me just make that a little bit bigger. And you see the green squiggly lines on here. If I hover over this, it will actually state you that there's a SQL connection string in code in there. And of course, yeah, I was stupid. I persisted my password. And as you can see, this will hurt bad, of course. But the cool thing is that it will actually give you a better understanding of what's going on if you just look at the warnings underneath, because the warning itself will actually show you that there's a connection string in source code, validate, rotate, and remove the secrets in the file, and it will give you a full explanation of what you actually did wrong. If you click on this, you will get actually more information, as you know. So this is a very useful tool if you're still using 2017. Unfortunately, it's not compatible yet with 2019, but I think that way they will come probably once more. Of course, secure scanning of your code is one thing, but what if you could make your code more securely built from the ground up by the standards, the patterns and practices that we have and that we know from our internal organization? And what if you could just have an analyzer of your code that will actually take a look at your code and give you intelligence on security, what you're building? Now, there's also one for those. There's a plugin for both Visual Studio and Visual Studio Code. So freely downloadable from the Visual Studio Marketplace. And what it does is, if you take a look at the Visual Studio itself, here you can see that there's red squiggly lines. You get a good highlighting of some quick actions as always. And here you can actually see HTTPS, or I don't know whether you can read it well. HTTPS or HTTP option is insecure as it allows the use of HTTP plain text for content request and transfer. Use shared access protocol HTTPS only. So what it does, it scans the namespace and the classes that you're using, and it will give you actually better results on the full security of your application. It does a lot of things. It gives you errors whether it's really, really risky, or just warnings when there's a little bit less risk at hand. And it will give you a full overview when you take a look at the full Graph API of the results sets that you get back. So there's good documentation existing on those. And it works for both the VS Code and Visual Studio as a plugin. So, and it doesn't even slow down your development that much, or not even any, because I haven't figured out any performance loss in Visual Studio from that part. So as you can see, there's a lot of results that it gives back depending on what you're implementing and what you need to check on. But for these are, like for instance, AAD specific samples, but there's also samples for other things like service bus, where you also get here. No, there's nothing in here that is actually giving an issue. But as you can see, there's plenty of results that you can have from that plugin. No questions so far? If there's any questions in the YouTube channel, please post them to the Skype chat, because I cannot see the YouTube channel. All right. Now, of course, when we're doing the build, one thing that is also always lightly forgotten is setting the correct permissions for developers and repository owners. Whether it's GitHub or Azure DevOps, make sure that you set the right permissions to all of your developers and all of your stakeholders that are in a project. Because if they have source control, they can actually take a look on how your code is working, and they can try to sneak in some ugliness there, because not every security risk is coming from the outside. A lot of security risks are coming also from the inside, and you should always assume breach, even from a development perspective. So make sure that you set all the security settings correctly on your project owners, on your developers, on your contributors, on your readers, and that they don't have any excess access to any of your repository, especially if they're like risk bound, because you also need to audit. If you're working, for instance, with CMMI methodologies, you should also risk bound and access your repositories and your security on your code collaboration platform. That brings us to the next part, which is really the SecOps part. From there out, we make the slide flow into the building part, because typically you develop your code and then you can do some, as I showed you with some Roslyn analysis and some other analyzers, some security analysis. There's plugins for other plugins for Visual Studio that can do code analysis. ReSharper does some of that stuff. So there's plenty of stuff in there. But what if you need to do it in an automated way, and how should you react to this? Well, from there out, we bring it up to the secure build. And when we're doing building, whether it's GitHub Actions or Jenkins or in this case Azure DevOps, and why I showed Azure DevOps in this part is because of the visual representation of it, because that way I can show it pretty nicely. There's a lot of plugins that you can download, and most of these plugins work for all platforms. Yeah. And as you can see, there's a plethora, and I know this is pretty small, but this is just a grab of what is available in the marketplace from Azure DevOps. And there's plenty of more, because as you can see, the scroll bar is pretty long, and you can just keep on scrolling and scrolling and scrolling. What you need to do is, if you want to take a look at what is existing and how they work, and I will demonstrate some of these and show you the benefit of some of these, just look for security in the search bar, and it will give you all the correct results. Now, some of them that are really interesting, I'm going to show you here, where you can also have some additional benefits in combination with the Azure platform or behind that. Like, for instance, the AZSK. Since we're talking about Azure as a deployment platform, and we're talking about development, the AZSK is a toolkit that we built to make sure that we also do Azure secure deployments. Everything what we do inside of Microsoft is actually using this, and the guys that built this said, well, this is actually pretty good, and we should bring more security to the world. Let's open source this thing. So this is now available for your own use. And what it does, it's built up around 6 pillars: security provisioning in your subscription, develop securely, and this is where the security intelligence comes from, because this is part of the AZSK. They have a secure deployment from VSO, or in this case, Azure DevOps or GitHub or all these things. There's also periodically scanning, security dashboards, because there's implementations on log analytics for that, and additional custodial queries that you can do, and make data-driven improvements to security based on cloud risk governance that is built in from the documentation part and from the best practices part. Now, the one thing that you typically do if you want to do the standalone part is the scanning of the subscriptions, or the scanning even of an ARM template. It comes with a PowerShell. It comes with a PowerShell module called AZSK. Makes sense. You can just download it by doing git install module AZSK and allow Clobber and Force and to all users. And what it does, it gives you a full set of, and I have it here somewhere, a full set of commands that will actually allow you to either install the monitoring solution and continuous assurance, do an assessment of your entire environment, get access tokens, but also get the status of your services, of your subscription, or even a template that you do. And I already did the scan right before the beginning of this presentation. What it does, it will give you a from the scanning, it will give you a path back, and I need to make sure that I do it correctly. There we go. It will give you a path back. It will create you a couple of files. There we go. It will create you a couple of files, and one of them is a CSV file where you can see all the vulnerabilities that were created inside of your ARM template or inside of your subscription, and that you need to actually fix. Some of these are redundant. Some of these are complementary to things that we see today in a tool called Azure Security Center. And it's best to use them together, and you can use these same outputs or the same failings as a gated deployment. So if we take a look at the Excel file, just to give you an idea, what you have here is a full Excel file. Let me just do this. And let me just give you the data back as columns. Here we go. Yes, delimited. Here we go. Next. And it's a comma. There we go. Next. And finish. And from here out, you can actually start creating a Power BI report or whatever you want. But at least you get an idea what you need to do. Like, for instance, minimize the number of admins. These are some of the things that are being implemented in the Azure Security Center, but also things like do not use custom-defined RBAC roles for these and these reasons. And these are sometimes the recommendations are very well explained, what you need to do and how you can fix all these things. So as you can see here, so this is very useful for a reporting part. Now, if you always need to run this scripting part, it's going to be cumbersome. It's good to have a check if you want to do a pre-check on your PC before you're checking your ARM template, for instance. But you can also do this in an automated way. So if we take a look at our Azure DevOps environment, for instance, here we are. We have here a build pipeline where we have, is it this one? I need to make sure that I pick the correct one. Yes, it's this one, where we actually have implemented the ARM template checker. If you click on this thing, you can actually see the result back, and it gives you all the failed results back. So the failed ones means that those are the things that you need to fix and that you need to worry about. And if they pass, then all is well. And as you can see, my deployment is actually pretty sucky because I have a lot of failures there. But then again, that's for the course of this presentation, of course. There you go. And there's plenty of more in that toolkit too. Now, I already talked to you about dependency scanning. For those who remember the dependency of the padding left in one of the new NPM packages 2 years ago that brought on the entire internet. This is one of the reasons why you should do dependency scanning. That was not an malicious piece of software, but there was rather so many dependencies were depending on that dependency that it's actually failed the world. And this will actually give you better insights in how your software is depending on other pieces of software, but also on the vulnerabilities that are in there. There's a couple of international databases that are being used to feed these tools, and they give back results on how to mitigate the risks in there, but also maybe some licenses where you applied the wrong license inside your own software, and so on and so on. Now, one of the most well-known is WhiteSource, and WhiteSource Bolt is the free version of this, and you can easily implement this in Azure DevOps too. If you take a look at our browser again, I have a, it's this one. No, it's not this one. It's the other one. Here it is. New. I lost my browser. Did I close it? No. Okay. There it is. What I have here is I also have a white bolt report, as you can see here, and it gives you back a vulnerability score on the overall. And you see all the libraries that are not vulnerable, but especially the ones that are vulnerable and outdated. Those are the ones you need to update. You get a fix on these things. You see the vulnerability that's being addressed. Not every thing that you have can be updated. I understand that, but that means that you need to worry about the sanity of your entire application. So maybe you need to start building a vNext and start fixing these things. You also see all the eventual GitHub bulletins that are regarded to that. And if you take a look at the build itself, it's just a graphical interface because I love the graphical interface. I understand everybody should be doing YAML, but this makes it easier to understand what you're doing, and it's just implementing this plugin very easily and just setting a display name, what your working directory is, and that's it. Nothing more, nothing less. And you can start working on it, and it will update also because they push the plugin back to the DevOps environment. So if you take a look at another application, like for instance this one, if all is well, this should be loading pretty nicely too. You get a totally different view on these things. So depending on how sane your code is and the vulnerabilities that are in the dependencies that you have, you get a totally different results. So this is something you should be doing because you really want to keep an overview on what is happening with your software from a third-party perspective too. Then we have Snyk. Snyk is pretty cool because it can do more than just scanning for dependencies from within your build pipeline. It will scan your GitHub repositories. It will scan your Azure repos. It will scan your container registries. It will scan your container images. And even from that perspective, it actually integrates back into Azure DevOps as a report. It's pretty cool to see that it can work directly on the code. So every single time you do a check-in, it will start a scan. But if you do it in your build pipeline, as I've done here, you can scan it on either code level or container level. This is on application level, for instance. And the only thing that you need to do is get an API. Snyk is totally free for open source development, but also for your own source development. You get just a limited number of build minutes that you have back. And you can actually already do a lot, just limited in the number of projects that you're doing too. And if you take a look here at the build itself, then, and the build results, you actually get some nice, now I need to, of course, open the builds. I need to do the Snyk report on this one. You get a nice report back inside of Azure DevOps if you implement that plugin, giving you this more or less the same vulnerabilities back if depending on the npm packages, and a little bit more too. All is well, this should be loading correctly. Just try another build. It was loaded before. Yes, this will be better. So if I do this one, yeah, now it's loading correctly. As you can see, it found 15 issues. They give you dependency paths, also the vulnerabilities. It gives you good information in inventory on the dependencies. So depending on what you like more or less, you can choose either WhiteSource Bolt or this thing. But this one does a little bit more, according to me, and it gives you a better overview of what's going on and where everything is related to your code. Also from the dashboard that they built themselves, you also have implementations directly on your resources, as you can see here, and then you can immediately go back to your code and start drilling inside of your code dependencies that are created there. Now this one is inactive, but if I would have clicked an active one, you would have seen something more interesting, right? A very cool open source tool which does more than security scanning alone is SonoCube. If you're taking coding seriously and you take technical depth seriously, then SonoCube is your solution. Why? Because it gives you a good overview on where the amount of work is still had to be done, but it also gives you a good insight on all the OWASP vulnerabilities that you have in the OWASP top 10. And for those who don't know what OWASP is, these are the open web standards for application security, and these range from SQL injection to cross-site scripting to all these ugly little things that you typically want to avoid, and that penetration tester or security engineer will probably scan for. If we take a look at the results, again, this is something that you can easily implement in your build pipeline. You have 3 simple steps here. If you take a look at the build pipeline itself, what you first need to do is you need to set up and prepare the analysis on SonoCube, and this is where you point to your SonoCube server, because it's a SonoCube server. They also have it in a hosted model, which is called Sona Cloud, which you don't have to do a lot of preparation for, just point and click, just like Smith & Wesson, the perfect point and click solution. But for this one, you can set your own properties, your own project names, some dependencies on different kind of database servers that you want to use. And then you do a build, and then you do your code analysis, and you publish your quality gate result. And this will give you a full view on your application from a technical depth perspective. And as you can see, there's no vulnerabilities in here. But if we would take a look at possible issues, you can actually have a security report either by OWASP top 10 or SANS top 25. If I click on this, you will actually see possible issues that could be found in your code, where we have injection coding, broken authentication, security misconfiguration, and so on and so on. As you can see, there's 2 non-OWASP vulnerabilities here, and there's 44 open ones. And this brings you to a full reporting, which can bring you back into the code and can start drilling down deeper on those. If you buy a enterprise license on these things, they have like graphical reports on this, but here at least you have an overview on how your code is reacting and where your vulnerabilities lie. So if you have a SQL injection line of code here, it will highlight and it will actually start burning up inside of your security hotspot. And you can easily just like granularly take a look at all the different reporting from this tree view on the site. So very useful. And again, it gives you more bang for buck because you have like code quality, you get churning reports, but you also have things like cyclomatic complexity and all these things that you have from FXCOP and all these things that you typically do in your Visual Studio code analyzes, they can be pushed back in here. Even resharpered results can be pushed back in here. So a lot of things can be pushed in here without leaving your build environment. There's also security code analysis, and this is for if you are a Microsoft Premier contracted customer. What we have is, and this is very good to take a look at, this is a, I'm going to show you, come on, didn't open. SecDev Tools brings you to this website. It will implement one single plugin and you get all these tools. So you also have GridScan in there then, but BinSkim, additional Roslyn analysis, Microsoft risk detection. This is especially useful if you're building applications, not really web applications, but applications. So like C++ and C# console applications stuff. We also do anti-malware scanning, and we have post-processing of these results and security reports that are generated. Typically, they output the results back in the build results, and you can just download them from your build pipeline afterwards. And as you can see, there's some implementation. No, not in this one. I think it was in this one that I implemented it. If you take a look at the edit here, as you can see here, you can do code metrics, GridScan, just plugging in, but you need to, your subscription on Azure DevOps needs to be allowed. And then from there out, you can start using them. But it's only when you have a Premier support contract. But really worth it because it will help you identify other things also next to the things that I've always shown you. Then we talk a little bit about secure deployment. First of all, and I see that I'm always running out of time, so I need to hurry up a little bit. First of all, if you do deployments, make sure that you also in Azure apply RBAC. As a best practice, always follow the principle of granting the least privilege. So making sure that people don't get too many permissions or too many privileges. Make sure that that scope is inherited to all children of the assigned scope. And also make use of service principles of managed identities as much as possible, because this will not only make your life easier, but also make your life a little bit more secure. From a governance perspective, you can actually deploy some of these things through the means of blueprints and policies. Policies will enforce you to either not deploy some stuff or not do things that you aren't allowed to do. That's also a security principle. And the RBAC, this is where you already set your permissions and your security on top of your Azure subscription. Blueprint will help you if you have multiple subscriptions and you want to maintain a full same scope on all your subscriptions that you're maintaining in your organization, and this will make it easier to deploy it with a single piece of deployment. It's easy to compose. You define all your artifacts and you just secure everything, and then you hook it up to a and up to your subscription or management group, and all is done from that single point of view. And if you take a look here, what you can do, it's policy definitions, ARM templates, role-based access control. And it can easily be hooked up to something if you have like governance and legal requirements like ISO, FedRAMP, or NIST. There's also blueprints already available for those if you want to implement them on those levels. Last part is the security center. So that brings us into the monitoring. AZSK does some pre-monitoring. Security Center does after the deployments. And one of the things that are new in there is actually the security scanning that we do on the level of containers. Because today we scan for vulnerabilities inside of containers. It's there since Q4 last year. What we have there is, if you take a look at Security Center itself, you have your secure score. And if you take a look at compute, this will actually bring you to the compute tab blade. And you have this part here called containers. It's a little bit too big for me, but at least you can see it. And what it will give you there, it will scan actually your images inside of your repositories, your registries. And it will give you recommendations on things that can possibly go wrong. Like for instance here, this container I created on purpose with some issues that are in there. And as you can see here, there is the threats that we have are there's data exfiltration, and the things that are the security checks that have been found are like there's a GNU bash privilege escalation vulnerability, so I need to update that. I need to update my Debian, which is the underlying image for my container image. And there's also a denial of service vulnerability in there that I need to take care of. And this is being done from the moment you publish your container image inside of the registry. Security Center will do the scanning, and it will give you back this report. This is something you need to activate, but totally worth it, because it can actually save your life after the fact. Wow. Seeing that it is time, that brings me to some resources that I have. So in all these tools, I have some resources that you can use. And there's also still something called Microsoft Learn, where you can find additional information. So, questions?
So yes, we are hurrying towards our break, but we can certainly do 2 questions, I think. So, Joao, I hope I pronounced it correctly. asks, is there any recommended Terraform static code analysis or security scan for Azure?
For Azure, if you're doing pure Terraform, there probably will be some. I've seen some tools in the wild that are out there, so it's worthwhile checking on them. I don't know which one is the best. If you're using them in combination with templates, you can definitely use AZSK in combination with Terraform then. So that's one thing you can do. For other things, I don't know, maybe there's an analyzer by Terraform itself. I have no idea. Should take a look.
Okay, and other question from John from Ireland. How does Microsoft ensure that all those third-party plugins are safe because they scan all your code? Great question.
Great question. So I don't know. Does he mean the ones that we implement or the ones that are you using, or you're scanning your code? We only scan. We don't scan your content. We scan the things that we find back that are exposed to the outside. So we inject some code. We see the result coming back. We actually don't know what's in there. But then again, if you're using GitHub, there's also security features in there that are doing the scanning. If you're doing GitLab, there's also security things that are being scanned. And I mean, they do the same thing. There's no difference there. So you need to have what it does. Probably it does some obfuscation on top of that, and then start doing it. It's actually a very confusing question, but it's really good one. You should figure that out together, Susanna. What do you think?
The best questions are sometimes very confusing and very hard to answer. So thank you for that question. Thank you, Mike, for this amazing talk. It was mind-blowing. A lot of stuff in there. So thank you for sharing this with us. We'll go through a short break of about 9 minutes so we can set up the next speaker, Dana, who will talk us through the right way to do Azure functions in Python.
All
So
right,
thank you, Mike.
Thank you.